So now that we got the important concurrency-based concepts that exist in Go, Goroutines and channels out of the way, and we got a rough first understanding of how these features work, I want to apply these features and some other features to this big project we worked on in an earlier section. Now, in case you did not follow along there, that's no problem. Attached you find my latest code snapshot, so that you can simply use that and continue with that. And my goal now is to add some concurrency features to this application here. Now, you could definitely become creative and try adding concurrency features everywhere, but I don't think that this is necessarily required for this program here. Now, actually for this program, it's probably not required at all because it already is pretty fast. But to simulate a slow program, I'll go to the file manager, and there, let's say when we write our data to the disk, so here in write result, we introduce some delay. Some deliberate delay with help of the built-in time package and its sleep function. Here we can sleep 3 seconds, for example, like this, to simulate a slow file writing process. If we do that, and we then save this, if we run the program, it will take quite some time to finish, because at the moment I have 4 tax rates, and if we take 3 seconds for every tax rate to write its results to the disk, then this will take 12 seconds overall. And therefore, indeed, now we have a scenario where Goroutines could make sense. And for that, I'll start here in the main.go file. Because it's in this file that I call process on my price job struct. And this struct, in the end, is responsible for starting all the other sub-processes, you could say. So for reading data and writing data. Hence, if we could run this main price job process here as a Go routine, we should be able to significantly speed up the overall program. Therefore, here in main.go, I'll start by running price job process as a Go routine by adding the Go keyword in front of it. Now, Go routines don't return values, so storing the error or trying to get back any other return value and storing that won't work. Instead, you'll have to use channels if you want to transmit data. And I'll get back to that. I'll therefore also comment out this code for now. But with that, we essentially have the same program as before, but now this task here is ran as a Go routine. And therefore, of course, all the other tasks that are started by this process method will be part of that Go routine. Therefore, if we save this and we run the program, it now finishes instantly, which is great. It didn't take that long, but it actually also didn't work as expected. As you'll see if you delete these result files, and we then run this again, you will see that no new files are created. So the program did not work as intended. And of course, we have the same problem as before, essentially. These processes are started in parallel, and Go doesn't keep track of when they're done. Instead, it is done after all processes started, and therefore the program exits. And that, of course, is not what we need here, and not what we want here. As a solution, we can again use a channel, or such an array of channels, and that's what I'll do here. I'll add my doneChans variable here, which will contain a slice of channels, where every channel, let's say again, gets a boolean, but as mentioned before, channels can be used to transmit any value, as you will also see later. And I will create an empty slice to begin with help of the make function, though it actually should come with a couple of elements, which then just should be empty elements, essentially. But of course, I know how many channels I'll need, because I have a fixed number of tax rates here. And I'm then using these tax rates here in the for loop, and therefore I will start as many processes as I have tax rates. So here I want 4 empty slots, or to make it a bit more dynamic, the length of tax rates, this number of slots, which of course is 4 in this case. So with that I have my channels, and now in this for loop, we can actually make use of that index, which we get from that range keyword in the end, and create a couple of new channels for the different indexes, so that we replace the empty slots that were created by this make function. And I want to replace these slots with new channels that will receive a Boolean value, or that will transmit a Boolean value. And as you learned, we create such a channel with help of the make function. So now we create one new channel for every tax rate, and we can then pass this channel to process, so that process can let us know through that channel once it's done. So I'll grab that channel and pass it to process. Of course, at the moment, this gives me an error because process doesn't want a channel. But of course, we can change this. For that, we should go to this process method and there accept a channel that will receive a Boolean. And I'll name it DoneChan here, though that name, as you learned, is up to you. And the idea now simply is that we send data through that channel once this operation here is done. So at the very end of it, after we executed the right result. Now we should get rid of that return statement here, because as mentioned, when you execute a function as a Goroutine, its return value is ignored. It's not supported by this feature, and therefore we don't need to return anything here, and therefore we can actually also get rid of this return type, error. If you, of course, would have places in the app where process is still called as a regular function instead of a Goroutine, you could keep that return type so that you can use this method both as a Goroutine and as a regular function, or a regular method in this case. But here that will not be the case, so I will actually get rid of all that, and at the moment do nothing in that if statement. And instead here at the end, after we called right result and we waited for that to finish, I will pass a value into my done channel, and here I use the value true, but you could use any value. So with that, we got this code here in process, and this code, as I just mentioned, will be executed step by step. Just because this process method is started as a Goroutine does not mean that all the functions in there are started as Goroutines as well. Instead, they are still processed as before, and it's just the overall process method that started as a Goroutine, so that multiple processes can run in parallel. We could start more Goroutines in there if we needed to, but here I'm happy with that current approach. It is important that we send the data through that channel though, so that in main.go we can wait for that data, so that we do know when we're done. And for that here, we can use another for loop, since I have an array of channels here, and go through that array of channels, so that I got my DoneChan here with the range keyword like this, and I then read from every channel. And that simply tells Go that we wait until every channel here has emitted one value, and then thereafter this main function finishes, and the program therefore exits. Well, and with that, we now can save everything and run this again, and you'll notice that now it takes 3 seconds, because that's the time it takes to write data to the disk, because of that sleep function we added here. But then the program is done. And we don't have to wait for the 12 seconds from before, because we now ran all these processes in parallel. So it was now just the longest taking process that mattered, instead of the sum of all process durations. And as you can see, we still got our result files here. So that all worked as before, but now with help of Goroutines and channels.